The BeyondTrust platform for privileged access management includes privileged password and session management, secure remote access for employees and vendors, and cross-platform endpoint privilege management. If you need to manage privileges on non-Windows systems, then endpoint privilege management for Unix and Linux is the solution you need. It enables privilege management on Mac, Unix, and Linux systems, and even on network devices. In this demo, we'll focus on host-based privilege management, where once users log into a host with some user account, they can then elevate and perform authorized tasks using a root or some other privileged account. We'll also show you how BeyondTrust records everything for auditing purposes. Prior to implementing endpoint privilege management within Unix and Linux environments, most organizations struggle with two major challenges. The first is a distributed policy, and the other is a lack of oversight. With endpoint privilege management, you can solve those problems by allowing for both centralized policy and centralized auditing of what people have done with privileges. First, privilege management for Unix and Linux gives you fine-grained control of root accounts or any other privileged users. So if you have certain service accounts or Oracle-type accounts, those can be the run-as accounts. Second, anytime we allow a user to have more than standard rights, we audit that user's activity. This helps protect against unauthorized changes within your environment. Finally, privilege management provides monitoring and session logs. This is more than just a text file or a report on elevated user activity. We can also provide session replay, so you can see the exact commands that were typed along the way. This session replay information is indexed and searchable. Endpoint privilege management for Unix and Linux has the following core components. First, there's a client installed on a server. This is used to initiate any sort of elevated commands. These commands are sent off to the second component, which is the policy server. The policy server evaluates the policy and decides centrally, based on your business rules, who is authorized to run what commands, where, when, and as who. These commands are recorded in the event log, so we know which commands were attempted and whether or not they ran elevated. We also have a session recorder, where we can start an I/O or session recording on the policy server before we elevate the command. And the final piece is the agent, which runs the command as the run user, effectively starting the I/O log or the session recording. This architecture allows for both centralized policy management and centralized auditing. We're not capturing logs or sessions locally on the machine where the user has been given root access. We're actually capturing all of this off the host the user's logged into and where they're trying to elevate. In this demonstration, we'll run through a discovery and deployment phase. Then we'll take a look at endpoint privilege management in use, using it to elevate. Then we'll take a look at the audit trail we leave behind. Here I'm logged into my desktop as the end user. We'll start by logging into the BeyondInsight Unix and Linux user interface. Now everything we do from within BeyondInsight Unix and Linux, we can also do from the command line interface. Which one you use depends on your goals in the environment. For example, if you're looking to deploy across tens of thousands of machines, the CLI may make the most sense. But if you're doing policy management, the web UI is the way to go. The first thing we see is a dashboard view of the various hosts across my environment and what policy and log servers they're using. Next, we'll start off with Discovery and scan for any new systems in our environment. Here we enter the host range we'd like to scan and click Submit. The scan is usually very quick, and when we navigate to our list of assets, we now have Lin 5 and Lin 7, in addition to the systems we've already identified in my environment. Here you can see when each system has been updated, what agents are deployed, and whether they've been joined to Active Directory with AD bridging. In addition, you can see whether privilege management is using the policy server or the submit and run host. Also, you can see the new systems we've discovered in the IP address range. These need to be brought into the fold of endpoint privilege management. To do this, we go to Perform Actions and choose Profile. We'll use an account that's already configured to log on. We don't have PMUL deployed on these systems now, so we're going to elevate with sudo, and we'll profile these two hosts. As we refresh our systems, we can see that these are ready to be installed, but they have no components installed on them yet. So under Perform Actions, we'll go back to Manage Software. In this case, we're deploying 2 at a time, but you can deploy our solution across multiple hosts very rapidly. So we'll choose Privilege Management for Unix and Linux. As we install, we can define roles. Do I want to make it a policy server, a logging server, or in this case, a submit and run host only? We'll select the host we want to deploy on, point them at a policy server and a logging server. This is a credentialed account, and while we're elevating with sudo, note that you can also pull managed credentials from BeyondTrust Password Safe. So for example, there might be an account out there that has rights to install software, but Password Safe itself is rotating the account passwords or keys at set intervals, so nobody knows what they are. And then we can allow that account to be used through the web UI without having to disclose those passwords. But for now, we'll just install Endpoint Privilege Management for Unix and Linux on both hosts. While that's running, notice that you do have access to the task panel, where you can see events as they're happening. You can also view the details of these tasks, but now that they've completed, we can return to our host list to verify that the client installed. Now we can log on as that user. As you see, I didn't have to enter my login credentials. This is due to our AD Bridge solution, which allows you to take your Unix and Linux hosts, join them to Active Directory. Then when you need to access a Unix or Linux resource, rather than re-authenticating on every single host, you can use a corporized logon, which allows for single sign-on onto the host based on that user's group membership. And you can see this user as part of domain users. Now we'll use the pmul command pbrun and then show. Show is going to output a list of the various commands or sets of commands that this user is authorized to run. So I'd like to start off with some basic command elevation. In many ways, it's very close to what you might get with sudo, only it still has that centralized policy options in the background. To elevate, we do pbrun id, and we can see this additional dialog here has been put in more for this demo. You can customize how much or how little dialog to put in front of the user when they're choosing to elevate. So pbrun id was sent off to my central policy server, and the run user is going to be root. And here are the results of the command. So that's a basic type of command elevation. In addition, there are more advanced commands like Docker or even some SQL plus type of configurations. Now let's jump over to another system. Here we'll log on as another user, and again I'll enter pbrun show. Now this user has access to the same types of commands. In this case, though, we're going to try to do something more advanced, such as edit a configuration file. So I'll enter pbrun edit hosts. Traditionally, edit hosts is not even an actual command. However, pbrun sends the command off to the policy server. The policy server will decide whether to elevate the command, and then it can instruct the agent to do whatever we'd like. So in this case, I can submit the edit host command and have it run vi against the host file, giving admins the ability to say, make a change. With privilege management, we're auditing everything. Traditionally, if you were to give a user vi as root, that would provide them the ability to essentially escape out. But here, endpoint privilege management ships with restricted binaries used for editing software. So pbvi is actually the only thing my user has the rights to launch against the host file to make changes. So we can make the changes we need to, but I'm not going to allow the user to escape out and grab a bash shell as root. That's just one of the options the restricted binaries give you with endpoint privilege management. Additionally, since we did make changes to that configuration file, we want to ensure that we know the way it looked before and after. So here's our IO log that's going to be centrally stored out on that server. So with command elevation, the user is not able to escape out even when we've provided access to vi. Additionally, we don't even have to be logged into that server. The run and the submit host don't even have to be the same host. For example, if I wanted to run a command out on another server, I can prefix it with h plus the server name. So this will run that edit host command, but rather than running it on the host we're on, it will open up the host file on the destination server. This is remote command execution. And you can see in this case, we came in and we made changes to a config file on a remote server without necessarily having logon rights there. This is possible because my policy defines what systems I'm authorized to submit commands from, or the hosts, and what systems I can have commands run or execute on, which are the run hosts. So in this case, we've submitted commands from one server and had them run on another, all the while capturing what took place. Let's do a few more examples. In addition to allowing users to elevate and log onto a system as Oracle or root, you can also just give them access to a component or tool or binary as that privileged account. So we'll do another remote command execution and run SQL+. That would look something like this: pb run to elevate, h and the server name to identify the remote server, and this user is authorized to run SQL+. And now our user has launched the SQL+ binary as the Oracle user on the remote server and can run SQL commands that are required. In addition to allowing remote command execution, we also capture everything that's typed, both input and output. These I/O logs are also indexed, making it very easy to search across one or multiple logs as needed. Now let's take a look at our Advanced Control and Audit, or ACA, options. ACA is used when you're wanting to restrict an admin who's accustomed to having root access, and you want to get them as close to that admin experience as they were before. ACA allows you to identify the commands you'd like to elevate and then begin blacklisting or controlling the commands you don't want the user to run. You can take this all the way down to the file system level. For example, if we wanted to give this user a root shell, we can do pbrun bash. And what that's going to do is ultimately elevate the entire shell as root. So now we essentially have that root shell at our disposal. That said, perhaps there are certain tasks we want to have this user avoid doing, or possibly we want to allow certain users that are in a group, such as Linux troubleshooters, to be able to go and look at var logs and examine that in more of a read-only fashion. Advanced Control and Audit allows us to do just that. We can control this user's interaction with the system at the file system level. So not just what commands can they run as root, but can they read parts of the file system? Can they write to them or execute them? And all the while we're auditing and controlling what's done within those actions. If a user ran a script before, oftentimes you wouldn't have visibility into what took place within that script. Or if that script had commands the user wasn't authorized to execute, they very well might execute using other systems or tools, but not with endpoint privilege management for Unix and Linux. So for example, we've just elevated there as root. We can see that we're root. We'll clear that off. Now let's take a look at the scripts directory. The one that we'll focus on in this case is going to be script 1. And we can do a quick lsltr, and it's clear that script 1 is obviously owned by root. So we'll do a quick vi on that script to see what it does. This script reboots the system, and then it decides to cat the shadow and password file. Our user, however, wants it to do a little more. So we'll make a change and save that. But the reality is, the user can't. Because the user is root and the script is owned by root, you'd expect them to be able to change and save. But this user is not authorized because they have a privilege management enabled root session. Endpoint privilege management controls what they can exec, what they can read, or in this case, what they can write, not the scripts. But let's make sure that we can run it. So we can see that the script definitely starts. It does its bit, but it does not reboot the box. And that's because even though we've given this user the ability to run the bash shell as root, there are certain binaries that we've blacklisted. Now let's exit and take a look at the audit trail we've left behind. We can look at this both from the web UI as well as from the command line interface. Since we're already here, we'll start with the CLI, and then we'll take a look in Beyond Insight, Unix and Linux. So I'll do a pbrun list logs. This shows all the logs that are held out on my policy server. This user is in the audit group, which allows for these commands. So let's take a look at the bash command. From this view, I can copy the file, enter pbrun replay, and replay that log file. So this allows us to see exactly what took place within that session. As I hit the spacebar, we go through character by character, I can backspace through this session. T will tell me what time it was when this was taking place, and then Enter takes you through line by line. We can see that the user came into that scripts directory, tried to make a change to the script, and wasn't able to. As this is happening, V will output a list of environmental variables that were in place during this session as well. In addition to viewing the replay, we can also take a look at history. And now we have a bit more information throughout that session. We can see, of course, the working directory where we started, ultimately where we went to, running off the ID commands, the whoami commands, and so on. And then we actually tried to execute that script from the scripts directory. And we can see which were executed, the cat or the shadow and password file because she was authorized to, but the reboot command was blocked. This is advanced control and audit. Not only do you have the advanced control to say what users can and can't do, even within scripts, but you can also audit what took place. That's what an audit looks like in the command line interface. Now let's review the same audit within Beyond Insight. Here we have both the event log reporting as well as session replay. The event log shows a list of who's run what commands, where, and when, and whether it was accepted or rejected. So we know the submit user, the run user, the command, the bash command, or so on. You can also query across these and you can download them. We can also view the session log. This will allow us to replay what took place. We can even query for commands that were entered. For this example, let's replay that full bash session. You have the ability to replay it like it happened. You can also take a look at the entire session at one go, or speed it up or zoom in as needed. On the right, you can also see the history being counted down. We can see when the user executed a script, as well as all of the advanced control and audit commands. Now let's go out to our central auditing server where all our logs are stored. We do have access to the event view. We can also look at the session replay. Anytime anyone elevates using PMUL, this is the audit trail left behind. When we want to control all of that, we do so within the Policy Management module. Unlike sudo, privilege management for Unix and Linux gives you granular control over user permissions and centralized policy management. To highlight this, let's take a look at the roles-based policy. This is where we define roles, and within each role specify the who, what, where, and when. And then, of course, we have the ability to back up or restore them. From here, you can drill down into individual roles. If we click Edit the Role, we can specify some details about the role and assign who is going to be authorized to run this role. Not only can we select specific users, we can also select groups of users. These groups could align with local groups, or if you're using AD Bridge or directory-based system, groups you've defined in group policy. So this is where we set the run user, and then the what. In this case, container management. This is a list of commands that we've associated with container management. And then finally, where. We can specify all hosts, or just have specific hosts that you'd like this user to be able to run commands from and have them execute on. And then the time of day. Is it all day every day, or do we want it to be more during business hours or work weeks? And these are completely customizable. So now that we've said the who, the what, and the where, let's take another dig down deeper into the actual what. So who is pretty simple, users and groups. But let's look at the what. These are command sets that the users are authorized to run. Some have been blacklisted, others are allowed. You can drill down into each set to see the specific commands included. You can also create custom commands if you like. Our roles-based policy allows you to select the who, the what, the where, and the when, and link that to a role. To conclude, we'll revisit our dashboard screen. We now have additional systems joined, and now it's all going to be covered. To reiterate, we have used Beyond Insight Unix and Linux to discover new hosts across our environment. We used that same tool to deploy endpoint privilege management for Unix and Linux on the discovered hosts, and that brought them into the fold, allowing for centralized policy management and centralized auditing of the commands and tasks that they ran with privilege. That's endpoint privilege management for Unix and Linux.